Okay, in this problem, we need to find the integral of 2x to the fourth plus 5x cubed over x to the fifth. The first thing that you should do here is take a moment to pause this video and try this out on your own. Once you've tried it out, let's go ahead and start this up. So the first thing that we want to do here is get rid of this fraction. When you're taking an antiderivative, generally fractions cause issues. Because when you're taking a derivative of a fraction, you need the quotient rule or some form of the chain rule, product rule, things like that. So the antiderivative, relying on those, would end up needing things like u substitution, which is a bit too difficult for these types of problems. Instead, notice that we have addition inside of the numerator of our fraction. Whenever you have addition or subtraction in your numerator, not in the bottom but in the top of your fraction, you can break that apart into two separate fractions, meaning we can rewrite this as the quantity of 2x to the fourth over x to the fifth plus 5x to the third over x to the fifth dx. These two problems are the same thing, and we could do a quick check to make sure. Because they both have a denominator of x to the fifth, we can add the numerators together to get 2x to the fourth plus 5x cubed all over x to the fifth. Now that we're here, let's start simplifying. We get the integral of 2x to the fourth over x to the fifth. We can cancel 4 x's from the top and 4 x's from the bottom, leaving us with just an x in the denominator. So we're left with 2 over x plus, again, we'll do the same thing, but with 3 x's from the top and 3 from the bottom, leaving us with 5 over x squared. Now that we're here, we have addition of two values or two functions inside of our integral, which means we can break this up into two separate integrals, leaving us with the integral of 2 over x dx plus the integral of 5 over x squared dx. Now the integral on the left and the integral on the right both have a constant that we can pull out. We're multiplying each of these functions by a 2 in the first case and a 5 in the second case. Let's bring those to the outside of our integral signs, giving us 2 times 1 over x dx plus 5 times the integral of 1 over x squared dx. And now, at this point, the left integral is something that we can take the antiderivative of. 1 over x we know is going to give us the natural log. So now let's just work with the one on the right. This way we can also get this into a form that we can take the antiderivative of. So we'll rewrite the integral on the left so that we can integrate both of these at the same time. And then the one on the right, we're going to change that from 1 over x squared dx by bringing this x squared to the numerator, giving us x to the negative second dx. And now we can apply the power rule to this x to the negative second, so we can begin our integration. So we get 2 times the antiderivative of 1 over x is the natural log of the absolute value of x, because if you took the derivative of the natural log of the absolute value of x, you would get x. From there, we have to remember that there's always a plus c, but because we have two separate integrals here, we have to have a plus c1. Each of these will get its own constant of integration. And we'll go ahead and put everything that we just integrated in parentheses with our 2 multiplied on the outside. Now let's repeat this. We have plus 5 times the integral of x to the negative second. We're going to add 1 to the exponent and then divide by our new exponent, and again add c, but in this case we've already used c1, so we'll get c2. So simplifying this, we get 2 natural log of the absolute value of x plus c1. We don't have to distribute the 2 to the c1 because it's just some constant that we're going to end up condensing down to just c anyway. So always remember these c's will just keep carrying down. You don't have to write 2c or anything like that. Now we'll keep going over here. We have plus 5 times the quantity of x to the negative first over negative 1 plus c2. And now we can distribute the 5, which again, we don't have to worry about multiplying it to the c. So we'll carry this up here, giving us 2 natural log of the absolute value of x plus c1. And then when we distribute this 5, we get 5 times x to the negative first over negative 1. That's the same thing as minus 5x to the negative first plus c2. So just to go through that one more time, this negative times our 5 gives us negative 5 times x to the negative first. We're almost done. We just have 2 things left to simplify, and that's just to bring this x down to the denominator to give it a positive exponent, giving us 2 natural log absolute value of x minus 5 over x. And now whenever you start with an indefinite integral, you always need to finish with plus c. Our c1 plus c2 just represents some constant c that we're solving for, so we condense them down into just c. And this is the antiderivative of 2x to the 4th plus 5x cubed divided by x to the 5th.